Hi, welcome back to my statistics class. So today we will have a more example about sampling distribution of proportion. Okay, so information on a packet of a seed claims the germination rate is 92%. There are approximately 166 in each packet. So discuss each of the conditions required to use a sampling distribution for the proportion of seeds that will germinate. Okay, so which three conditions? By now, at least you should remember the first two, right? One is independence. Second is randomization. Third is, since this is the proportion, not the mean, we have the success and the failure condition. Okay, which is NP has to be greater than or equal to 10, or NQ greater than, and not O, I'm sorry, and NQ, which is the failure rate, is greater than or equal to 10. Okay, independent. So what's independent? That means if you take out this seed, it's not going to affect the result of another seed. That means if this seed doesn't germinated, does it going to affect another seed? No, right? So this is an independent. And definitely randomization, because by an experiment, you definitely pick randomized. So usually the first two conditions is always met. So now it's the success and failure rate. So how many seeds in each packet? Is 160, right? And they tells you that, hey, the proportion, the success rate is 92. So we know that P is equals to 92. So Q is equals to what? Q is equals to 8%, right? So now let's check if they satisfy the success and failure rate. So NP equals to 160 times 0.92, which is 147.2, greater than or equals to 10. Now we still need to check the failure rate. NQ equals to 160 times 0.08, which is equal to 12.8. Oh, great, it's greater than or equals to 10. That means, hey, we can apply the sampling distribution for the proportion. Okay, so define the sampling distribution model and its parameter. So there are two parameters. One is the mean, the proportion mean, which is equals to the proportion. That one is easy. Equals to 0.92. Now is the standard errors, which is the standard deviation of the proportion, equals to P times Q over N, and then take square root of it. So we have 0.92 times 0.08 over 160. So now let me calculate that. We have square root of 0.92 times 0.08 and divided by 160 equals. Okay, so we have approximately 2%, 2.14 of, no, 0 to, I'm sorry, 0.0214. And then we know that, hey, this is follow a normal distribution. So we have our P hat follow a normal distribution with a mean 92%, a standard deviation of 0.214. Okay, sketch and label the model. So we have the distribution, the center is 19.2, and one standard deviation is what? We add 19.2 to 0.0212. So let's say this is a 0.02. So we have 0.94 for for our one standard deviation. This is 0.96, our third standard deviation with 0.98. And then to the left, we subtract 1 standard deviation, subtract 2 standard deviation, and subtract 3 standard deviation. So this is going to be our normal distribution. And we know that within the first standard deviation, this would be 68% of the area. And then within the second, within 2 standard deviation, this will make up what? 95% of the area. And within the 3 standard deviation, we have what? 99.8% of the area. Okay, so what's the probability that more than 95% of the set will be germline? So we're trying to find the probability when p hat greater than or equals to 95%, which is 0.95. So now look at the graph. I'm going to erase everything that, oops, sorry. So now they ask you, hey, what's the probability that greater than 95%? So we know that the center is 92%. So 95% is between 19.4 to 19.6, which is here, right? This is 0.95. We're trying to estimate this part, what would be the probability. So now let's use GeoGebra. So we have a mean equals to 92, and sigma, let's be more accurate. Instead of 0.2, we use 214. And then we want s greater than 95%, which is what? 0.0805, which is approximately, not approximately, which is 8.05%. So there is 8% that more than 95% of set will be germinated. So what would it be unusual for only 140 or fewer of 160 set to germinate? Why? So now let's take a look. 114 sets means what will be the proportion? What will be the ratio? So let's calculate that. 100 to 160. 114 sets to 100 for the whole packet, which is 114 divided by 160. Approximately equals to 87.5. And then let's say, is that unusual? So that means the probability when the germinate rate is less than this number. Again, we use a GeoGebra. So now we need to switch the x because we want x less than 87.5. So we got what? Approximately 1.77%. Okay, in the later I may show you more my open math homework to show you, to compare the difference. When should we apply to our sampling distribution of proportion? When do we use the S-bar, which is the sampling distribution of means? So I'll see you in next class.